Hello, uh, this is Mr. Creed back here again with another review video. So we're on the second ratio and proportional relationship page in your packet that was sent home this week. So this video is going to go through one. It's going to go. It's going to review numbers 1 through 4. We'll get 5, 6, and 7 in another video. Okay. So I want you to look at this page right here where it says Abigail mixes 2/3 pounds of walnuts with 3/5 pounds of dried fruit. Take a minute now, find that page. If you haven't done this page yet, do not watch the video yet. Try the page first before you watch this video. Okay. All right. So Abigail mixes 2/3 pounds of walnuts with 3/5 pounds of dried fruit to create more of the same mixture. How many pounds of walnuts does Abigail need to mix with 1 pound of dried fruit? Okay. So we got to let me pull up my pen here. So right now we're focusing on the 3/5 pounds of dried fruit. We got to make this into 1 pound. Well, you could do that by adding another 2/5 pound of dry fruit. That would make it that right there. But with proportional relationships, we always deal with multiples. Okay. So we got to figure out what can I multiply 3/5 by to get 1. Okay. Well, I don't know if you remember, but if you multiply anything by its reciprocal, it's always going to equal 1. Okay. So in this case, 3/5 times the reciprocal of 3/5 is going to be 5/3. Imagine just flipping that fraction. That's the reciprocal. You will get 15 over 15, and that is, in fact, just 1. So we're going to take now this 5/3 here. This is going to be our COP, okay, our constant proportionality for this problem. And we're going to take this, and we're going to multiply it to 2/3, okay? Because if we got to stay constant. So in order to stay constant, we got to multiply by the same number. Okay. So we're going to take 2/3. We're going to multiply it by 5/3. Now you guys know the rules with fractions. Okay, with multiplying fractions, you multiply fractions by multiplying across. So top times top, bottom times bottom. 2 times 5 is going to be 10. 3 times 3 is going to be 9. And that is about as far as it's going to simplify. That's its simplest form. 10 and 9 do not share a common factor except 1. Well, when you divide 10 by 1 and 9 by 1, you just get 10 over 9 again. So the amount of walnuts that Abigail will need to mix with 1 pound of dried fruit is going to be 10 ninths pounds. So LBS for pounds. Okay, 10 ninths pounds will be your answer for that. Okay. All right. I'm going to erase all this over here so I have some room to work some more. All right. Number 2, Brian makes 4 servings of pineapple mango juice shown on the table. Does the table of ratios show equivalent proportional relationships? So what I would suggest here is to make before I do anything, make these mixed numbers into improper fractions. Okay, so take a little bit of time now. I want you to convert those to improper fractions. Pause the video and come back when you think you have found the improper fractions for these 3 mixed numbers. Okay. All right. So I'm gonna create a T-chart here. I got 2 here, line there, and this. I'll tell you what. Let me move this so I got some more room. Because right now that little space is just not enough. T-chart. Okay. So I got 2, and I got 1 and 1 ninths. 1 and 1 ninths becomes 11 ninths as a improper fraction. Okay. 2 and a half becomes 5 over 2. We got 4 there. That remains the same. And then we got 3. And 4.5 is going to become 9 over 2. Okay. No, that's not written very well, but that's the best I can do with this little mouse I have. Okay. So imagine that the pineapple juice is X and the mango juice is Y. Okay, so we have created an XY table with the following amounts in the below. Okay, so I don't know if you guys remember, but we done a YKX triangle to determine the constant of proportionality. This is very similar to what you done last year with percent triangles, but we're not doing percents. We're taking this right here, and we are going to replace these letters with numbers. Okay, so all the x values would go in this bottom right corner. All the y values would go in the top triangle here. And k is what we're trying to find. K is going to be our constant proportionality. We need to know if this is an equivalent proportional relationship among all these 3 values here. Okay, so we're going to take all these numbers here. We're going to take 11 ninths. Okay, so we're going to draw another triangle here before I do anything. Okay, trying to find k. X is going to be 2. Y is going to be 11 over 9. Okay, 11 ninths. So k is going to look like 11 ninths divided by 2. Okay, so if you have a calculator, you can use that. I got mine right here. Okay, so we're going to do 11 ninths. And we're going to multiply that by 2. Okay, so let me find this here. So as a fraction, that's going to be 22 ninths. Okay, so my k that should be the same for all this should be 22 ninths. What you're going to do is you're going to take this amount right here, the 4 or the y, and divide it by the x. Okay, so I'm going to take 4 and I'm going to divide it by 5 halves. So 4 divided by 5 halves. That gives me, as a fraction, that gives me 8 fifths. So this k is going to be 8 fifths. Is this the same thing as that? No, it's not. So these do not, okay? So I'm going to erase this. These do not show a proportional relationship, okay? Let me get rid of this here. My pen back. So no, they do not, okay? All right. Reason why, they do not have the same constant proportionality all the way through, therefore they do not represent proportional relationships, okay? Now I'll rewrite that no here in just a moment. No. All right, number 3. Blake burns 4.5 calories in 2/3 of a minute riding his bike. What is Blake's unit rate? Reflect back to what we talked about this year and what you learned last year. Unit rate is in terms of a single rate, okay, meaning that 1. Okay, so in this case, we're looking at calories per minute. Okay, Blake burns 4.5 calories in 2/3 of a minute. Or Blake burns 9. Wow, I cannot write that. I did not write this morning. Try it again. Blake burns 9 second or 9.5 calories in 2/3 minutes. Okay, so we're going to take this and we're going to divide it by 2/3. Now, dividing by fractions are not fun. Okay, dividing by fractions are much easier if we do what's multiplied by the reciprocal. So remember the keep, change, flip method that you guys have learned. Keep, change, flip is the same thing as multiply by the reciprocal. Okay, so I'm going to change all this here. The first, I'm going to keep 9/2. Multiply that by the reciprocal of 2/3, which is 3/2. Remember, we multiply fractions by multiplying across. So multiply top by top, bottom by bottom. 9 times 3 is 27. 2 times 2 is 4. Okay. So Blake is going to be burning 27/4 calories per minute. Okay, this is Blake's unit rate. If you want to make that to a mixed number, that would be 4 goes in 27. Not quite 7 times. Goes in there 6 times. Goes in there 6 times. 6 times 4 is 24. Excuse me, and that's 3 left over because 27 subtract 24 is 3. Okay, so you get 6 3/4 calories per minute. Okay, this would be the unit rate. This would be the unit rate for that problem there. Okay. All right. Number 4, Harold can buy 2 pounds of bananas for $7. We need to write an equation to represent the cost C for B bananas. Well, we know that 2 pounds is $7. How much can you buy 1 pound for? Let's figure out that first before we write an equation. Okay, $7 buys 2 bananas. Okay, so if you take 7 and divide it by 2, that means 1 banana is going to be $3.50. So this is going to be our constant proportionality. Remember that the constant proportionality remains constant. So this price is going to be proportional as it goes, as the more bananas you buy. So we have our equation y equals kx. We have done this before. Okay, y equals kx is the general equation that we use for this unit. Okay, our k in this case is going to be 350. Okay, y is equal to the cost, so y equals cost. I'm going to put in parentheses C. Okay, and x equals bananas. Bananas, Bananas, or in this case, B. Okay, so I'm going to replace the y and the x with C and B. Okay, so C equals the constant proportionality, $3.50, 3.50, and then B is going to be multiplied to that because that's how many bananas you buy. One banana costs $3.50. So if I put 1 in for B, that is like 3.50 times 1, which is just 3.50. If I take 2 and plug it in for B, that is like 3.50 times 2, which happens to be 7. It costs $7 to buy 2 bananas. It costs $3.50 to buy 1 banana. Okay. All right. Got any questions regarding this video? Email me or comment on the video below. I'm going to be linking Mr. Miller's Periscope videos, so that way you can go check his videos out regarding Punnett squares. I think is this week is what he's doing. So genetics is what he's going to be covering. Again, any questions? Email me, and I hope you guys are doing great. We'll see you guys here in a little bit. Okay.